Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. It's great to have you here. My name is Lila Yuwana and I will give the lecture about the terminal velocity. Actually, terminal velocity is related to the fundamental physics, especially in free falling objects. But in the free falling objects in fundamental physics, there is an assumption. The assumption is air resistance is neglected, or there is no air resistance when the object falling to the ground. So we just have the equation v, the velocity is the square root of 2gh. H is the height of the object when started to falling to the ground, and g here is the gravity acceleration. Now let's move to our main topic, the final velocity. In terminal velocity, the air resistance is embraced. Now the consequences is the falling object will reach the constant velocity or final velocity, and we say as the terminal velocity. Now please look this figure. This is the free body diagram of the free falling object when the air resistance is embraced. The direction of the weight or gravity force is downward, and the direction of drag force or air resistance is against the gravity force. So the direction is opposite with the gravity force. Now, by using the definition of drag force is half of d rho a v square. D is the drag coefficient, rho is the density of fluid. In this case, the fluid is air. And then the A is the cross-sectional of area of the objects, and v is the velocity. Now we apply to the second law of Newton. Based on the free body diagram, we have expression mathematically as follows: mg minus r equals ma. A here is the acceleration of the object. Surprisingly, the higher velocity causes the higher of drag force. Now, because the drag force is increasing, it means the drag force is not constant and is not constant anymore. So the drag force will reach the same value as the gravity force. So if mg equals drag force, it means the acceleration is 0. Now, because of the acceleration is 0, now the velocity of the object when falling to the ground is constant. And this condition we call as the terminal velocity. The velocity when the object reach the constant velocity. So all the objects or skydiver when jumps to the ground from the plane, although the skydiver does not use the parachute, it still reaches the terminal velocity or constant velocity. But the velocity is still dangerous when the skydiver hit the ground. So I think the easiest way to make the skydiver safe when hit the ground is make the A higher, because the terminal velocity can be reduced by increasing the cross-sectional area of the object. It means the skydiver can utilize the parachute. This is the process when the skydiver reaches the terminal velocity. The skydiver actually reaches the final velocity twice. Firstly, when the skydiver haven't opened the parachute, and the second, when the skydiver have already opened the parachute. Now we can watch this video.
When a skydiver jumps out of a plane at 3,000 meters, the speed goes through some big changes.
This is when the skydiver will jump to the ground. And when they started to jump to the ground, it means the skydiver will experience the gravity force. The gravity force of the skydiver is constant. The green arrow here shows the gravity force. This is the constant value. And then when the velocity of the skydiver is higher, the drag force is show up.
Immediately pulls her towards the ground, and she starts to accelerate downwards. But
you can see here the velocity is higher, and then the drag force is emerged, and drag force is becoming higher, and then reach the same value as the gravity force. So the acceleration is zero and the velocity is constant without the parachute, but it's still dangerous and can cause the catastrophic impact when the skydiver hit the ground. Now the skydiver opened the parachute,
air resistance suddenly becomes much greater than gravity.
and then the drag force
No longer balanced, and this changes
is
her speed.
higher,
She slows down.
and the velocity is reduced.
Because she's slowing down, air resistance decreases until it balances.
And then
again,
reach the
reaches a much slower
terminal velocity or the constant velocity at 5 meters per second.
approaching the ground at 5 meters.
This is the safe velocity to hit the ground.
As she hits the ground, there's a thumping great counterforce from the Earth, which decelerates her.
Now next video show the skydiver jump to the ground without the parachute. It still reach the constant velocity or terminal velocity. But in this case, what makes the skydiver safe when hit the ground is using the large nets when the skydiver before hit the ground. Okay, you can see here, and as a conclusion, the skydiver, when started to jump to the ground, will reach the constant velocity. And in other words, the velocity of skydiver is not increasing all the time, but will reach the constant velocity. And the skydiver can increase the cross-sectional area by using parachute to reduce the terminal velocity, so they can hit the ground safely. Okay, thank you everyone. Assalamualaikum warahmatullahi wabarakatuh.